Hello everyone, welcome to this fifth lecture on waves. So in this lecture we will talk about something very special that's called beat formation, and beat is a very specialized kind of interference pattern that is formed between two superpositions of waves. So for example, two waves which are going in a particular direction, if they're superposed and if they have very slightly different frequencies and same amplitude, in that case there is something called beat formation occurs. So when two waves of equal frequencies or slightly different frequencies interfere with each other, then maxima and minima are obtained. So the intensities of these points remain fixed with time. However, if the two waves are differing in frequencies, maxima and minima will not remain fixed in time. Every point undergoes a periodic change in intensity between maximum and minimum. Alright, so this interference pattern is something called beat. So the phenomenon of beat formation or phenomenon of beat is defined as the periodic variation of the superposition of two waves of slightly different frequencies. Remember, the difference in frequencies, either the frequency should be little equal or slightly different, not much. Say 500 hertz and 505 hertz or 503 hertz, like that. Now, one maxima and the following minima combined together is known as one beat. So, if m is the number of beat per second, then it can be shown that m, which is number of beat per second, is equal to difference in two frequencies of the wave. Suppose nu1 is the frequency of the first wave, nu2 is the frequency of the second wave, then the difference in frequencies of the two waves give you the number of beats per second. All right. So here we consider two different waves. Remember, till now what we have considered regarding a progressive wave or a traveling wave is that we have considered a waveform of the form, say, y is equal to a sine of kx minus omega t. But for the case of beat formation, we will focus at a point where x is equal to 0. So if x is put to 0, then in this particular term goes off to 0, and you remain with something like a sine of omega t. And omega is, again we know, omega is equal to, say, twice pi nu. So twice pi nu into t. So for beat formation, we will identify our basic equations or waveforms to be a sine of twice pi nu1 t, where this is the first wave, we can say this is the first wave, say, and this is the second wave y2, and which has a frequency of nu2. Rest everything is same. See, amplitude is a over here, a over here. So now let us superimpose these two waves so that we get ultimate wave as y, which is equal to y1 plus y2. If you do that, you have to make use of a formula which is called sin c plus sin d formula, because this is like a taken common. You have got sine of something plus sine of another thing. So this is under the sin c plus sin d formula, which says 2 sine c plus d by 2 cos of c minus d by 2. If you do the same thing, like you will get twice a sine c plus d. I mean, I'm considering this term as c and this whole term as d. In that case, what I get, twice a sine of twice pi nu1 plus nu2 t divided by 2 cos of twice pi same nu1 minus nu2 divided by 2 into t. So let's write this term, cosine term, that is basically, let us write it with here and sine term on the other side. So in that case, if we shuffle this sine and cosine term, in that case we have y is equal to twice a cos of twice pi whole into nu1 minus nu2 t divided by 2. So this is the basic waveform that we get after superposition of two waves. Now this waveform can be written as y is equal to capital A, means this whole term is written as capital A sine of twice by nu t. And if I have to write this term as twice by nu t, in that case nu becomes nu1 plus nu2 divided by 2. This particular term I am designating as nu. So twice by nu into t. Alright, so this basically, actually, why we are writing this, because this simplifies our visual perspective of this wave, because we get it in the form which is familiar to us, that y is equal to a sine of twice by nu t or a sine of omega t. So that is the reason why I am writing it. So what is a? A is the amplitude of the ultimate wave or the superposed wave, and a is equal to actually twice a cos of twice pi nu1 minus nu2 t divided by 2. That's what has been written here. So it is interesting to note that the amplitude A contains the term t, t means time, which indicates that the resultant amplitude does not remain constant but oscillates between maximum and 0 with time. So consequently, there will be two cases, that when the amplitude is equal to 0 and when the amplitude is equal to maximum. So the two cases give rise to the conditions of maxima and minima in case of bits. So when the intensity of the resulting wave is maximum, then this term cos of twice pi nu 1 minus nu 2 divided by 2 into t, that should be either plus minus 1, that means either plus 1 or minus 1. In that case, this particular term which is inside the cosine term should be is equal to n pi, where n is equal to 0, 1, 2, 3, etc. Why? Once again, remember this particular circle. So this is the cosine line, this is the sine line. So this time I'm talking about n pi. N pi means where n is equal to 0. So either this point or this point, because this is 0, this is pi, this is twice pi, this is again thrice pi, this is 4 pi, this is 5 pi. So what is the value of cos in this particular point? It is minus 1. The value of cos at this point is plus 1. So if both plus minus 1 are the possibilities, in that case you will have the value of theta, that is cos theta is equal to, if it is plus minus 1, I mean this is quite like this, cos of theta is equal to plus minus 1, which implies theta is equal to cos inverse of plus minus 1, or theta is equal to n pi, where n is equal to 0, 1, 2, 3, etc. If n is equal to 0, cos value will be plus 1. If n is equal to 1, it will be pi, so the cosine value of pi is equal to minus 1. Like that, it will alternately go as plus 1 or minus 1. By the way, why plus minus 1 we have considered? Because in the amplitude term, you see, if cos is equal to plus minus 1, this the value of all whole, I mean this complete function has got a value of plus minus 1, either plus 1 or minus 1, then a is equal to plus minus twice a. So that's what is the amplitude, because we know, I mean from this is the mean position 0, so from here either it will go to plus twice a or it will come to minus twice a. So both plus and minus are a possibility for the maximum intensity. All right. By the way, actually intensity is equal to amplitude square. So whenever, another way of saying this, if you take the amplitude square, in that case both plus 1 square will also become plus 1 and minus 1 square also will give you plus 1. So that is the reason why whenever you are taking amplitude square, that means you are considering the intensity. In that case, both the halves of amplitude will be considered. That means both plus half and minus half. Alright, so that is the reason we are considering plus minus 1, and because of which the ultimate theta, which is twice by nu 1 minus nu 2 by 2 into t, that is coming out as n pi. So from this equation, if you just balance it, pi gets cancelled, these two gets cancelled, t can be written as n divided by nu 1 minus nu 2. So these are the times when you will obtain the maxima. So maxima will be obtained as, if you put n is equal to 0, so 0 by something is 0, so maximas will be obtained at 0, 1 by nu 1 minus nu 2, 2 by nu 1 minus nu 2, 3 by nu 1 minus nu 2, and so on. Alright, so these are the times when you will get maxima. Again, when you will get minima? Minima you will get whenever this particular term of cosine is equal to 0, so that twice pi of this is equal to, this time twice n plus 1 pi by 2. Alright, so once again, if you calculate for the time over here, that because these two gets cancelled, you've got a pi over here, this gets cancelled, so this remains as twice n plus 1 divided by 2 into nu 1 minus nu 2. So minimas are obtained at these times. Alright, now question is, what is a bit period? How do you define a bit period? Bit period is defined as the time interval between two consecutive bits, or it is the time between two consecutive maxima or two consecutive minima of the sound intensity. So it can be easily shown that bit period is 1 by nu 1 minus nu 2. Got it? Why 1 by nu 1 minus nu 2? Because if you take difference between these two terms or these two terms, you will get nu 1 minus nu 2, or if you take difference between these two terms or these two terms, then also you will get nu 1 minus nu 2. So it is either the difference between two consecutive maxima or two consecutive minima. Alright, So that is what we get beat period. So beat period, now how do you find the number of beat per second? Number of bit per second, you will get it as 1 by bit period. So it's just nu1 minus nu2. That's a direct proof. So thus the number of bits per second is equal to the difference in frequency of the two waves. Greater the difference, greater is the number of bit per second. That is, quicker is the variation in intensity. All right. So that's what is a very brief analytical treatment or theoretical background of beat formation. And let us see it visually, how exactly it looks like. Suppose there are two waves of slightly different frequencies. These two waves are of slightly different frequencies. Suppose one is of 500 hertz, second one is of 503 hertz. In that case, you see how exactly that superposition. This is a y1, this is y2, and this is ultimately y, which is equal to y1 plus y2, and see how exactly things are getting formed. There is a minima over here, goes to a maxima, and again reaching out a minima. All right. So this is one bit, one single envelope like structure. That's one bit. I mean, it would have been nice if you could hear to this sound, but it's a little difficult to make it possible. Someday, maybe if you approach, in that case, I can give you a demonstration of how exactly the sound looks like, or you can get it in any internet sources, right? This anyway, this diagram has been taken from internet sources. So that's all I have for today's class, the phenomenon of beat formation. In next class, we will talk about Doppler's effect, which is one of the very interesting phenomenon in physics, and you all might have experienced it. Because suppose you are standing at a position, suppose this is your location, and there's a train line, and a train approaches. In that case, before it approach and just as it pass by, you see or you hear a difference in frequencies or difference in pitch. So that difference in pitch or change in pitch or change in frequency is known as the Doppler effect. How exactly it happens, what is the physics behind, we will understand in the next lecture. All right, so thank you for today.